The Arduino Uno is a very popular platform. Using the Arduino IDE, even beginners can work easily and without any problems. But for larger projects, troubleshooting is often quite a foggy business. Tools such as console outputs change the timing and require additional space and the limited RAM. Now we need real hardware debugging. But unfortunately, the Arduino IDE does not provide for this. The solution to these problems is a board that is very cheap to buy, the Atmel Explained Mini. The Explained Mini looks a little different than the Arduino board, but is fully pin compatible. Both boards use the same microcontroller, the Microchip Atmega 328P. Shields that fit on the Arduino Uno can also be attached to the Explained Mini. The difference? The Explained Mini has an integrated debug interface called Debug Wire, through which the interior of the microcontroller can be observed directly at any time. And all this is really available for just 20 euros? For this we need the Atmel 328P Explained Mini board and a 40-pin female connector strip, which we divide using a cutter and some skill into once 6-pin, twice 8-pin and once 10-pin. The rest is shipping costs. We use the Explained Mini board for troubleshooting only. As soon as the software runs perfectly, we load it onto any Arduino and can immediately start our next project. As the Arduino IDE does not support hardware debugging, we use Atmel Studio 7 instead. There we can import Arduino projects and start debugging right away. What are the benefits? We can set breakpoints, display RAM, flash and EEPROM, monitor and even modify the internal processor registers, keep a close eye on the microcontroller in everything it does. How does it work? For this we need Atmel Studio 7. We connect the Explained Mini board, import an Arduino project, select our board as tool in Debug Wire mode and disable the optimization for C++, because this is the only way for debugging to work properly. A short click on Go, and the LED flashes. With Break All, we stop the process. Now step out until we find ourselves back in the loop. There we can set breakpoints, go through the program step by step, we can display variables, change variables, have a look at Flash or into RAM, and monitor and manipulate all I/O registers down to every single bit. Until finally our source code does exactly what we want it to do. We no longer need a console for debugging, and we look for our errors in exactly the code we programmed. After all, not a single line of code needs to be changed just to debug it.